Hey everyone, it's Mrs. Bokerman, and
Mrs. Casey.
we were going to be gone today, so we thought we would teach you via video. So we're going to teach you about principal solutions today.
So as you'll notice here on this first problem that we have for you, the question is, what is the answer to the inverse cosine of 1/2? Mrs. Bokerman, what do you think?
Pi over 3?
Okay.
5 pi over 3.
Okay. Any others?
7 pi over 3? I mean, we can keep going.
I guess we could. We could even go in the negative direction, right?
So we have to write all of those.
No, you do not have to write all of those. We have a way of determining one angle that gives us the solution to inverse cosine of 1/2. Each of our inverse trig functions have a principal solution range for the answers. The principal solution range for cosine inverse happens to be between 0 and pi.
So the correct answer to this problem would just be pi over 3. Let's dive in more to the principal solution. Okay, so let's look at this graphically. In red, we have the curve y equals cosine x, and in blue, we've graphed the inverse cosine. So I'm wondering why we have this red curve that's continuous, and yet the blue curve is not. So let's stop and look about the table of values for cosine. Okay? If I were to do this, the 5 points that I would use in my normal graph would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? And so the cosine of 0 is 1, 0, negative 1, 0, 1 again. So if I were to figure out the inverse, all I would do is I would switch my x and y values. So I'm going to write these as ordered pairs. So I'm going to have 1, 0. I'm going to have 0 pi over 2. I'm going to have negative 1 pi. I'm going to have 0, 3 pi over 2. And we have 1, 2 pi. Okay? So 1, 0 is this point right here on our graph down there. 0 pi over 2 is right on our y-intercept. Negative 1 pi is this point up here. Okay, so this is kind of where the graph cut off. Because watch what would happen if I graphed 0, 3 pi over 2. It would be way up here. Now I have something that's not even a function. Okay? Another reason that our curve is just going to stop is because these values in here are going to be all of our cosine values that are positive. These values are here are going to be all the cosine values that are negative. And we just need those for the principal solution. So this range is from 0 to pi for the principal solution for cosine.
Okay, so we're going to talk about the same thing with our inverse sine curve. And you'll notice just like on cosine, here is our sine curve in red, and we have our inverse sine curve in blue. And again, it is truncated. It is smaller, shorter than the rest of it. And so we want to figure out not only why do we only have these values that are here, but why are we going from negative pi over 2 to pi over 2? Why are we not going from 0 to pi like the inverse cosine? So I'm just going to again do a quick little table of values like we did on inverse cosine. So this will be x and y equals sine of x. And we will plot our important sine values, but I am going to plot a few extras. So let's say I have negative pi. Sine of negative pi is 0. Sine of negative pi over 2 is negative 1. Sine of 0 is 0. Now we have pi over 2 is positive 1. Pi is 0 again. So when I find my inverse values, so inverse sine of x, now I'll do the same thing like Mrs. Bokerman did. I will write coordinate pairs. So I have 0, negative pi, negative 1, negative pi over 2, 0, 0, 1, pi over 2, 0, pi. So when we look at the blue graph, we can see the point -1, negative pi over 2 is graphed. So that's this one. We have 0, 0, and we have 1 pi over 2. The reason that these two are not graphed is two parts. Again, one would be that we would create something that would not be a function. It wouldn't pass the vertical line test, so we don't want to include them. And we also want to make sure, just like on the inverse cosine, that we get all of the negative values from our sine curve and all of the positive values. So we need our graph to include positive and negative and also be consecutive. So this gives us the range of values for the principal solution set for y equals inverse sine of x.
Okay, so now we're going to talk about what are the other ones. So here is a list of all 6 trig functions and their principal solutions, and we will give you a second to write these down. Okay, so let's apply what we just learned. Okay, if I'm going to work inside out. I want to know what the sine of 2 pi over 3 is. And so I know that the sine of 2 pi over 3 is positive root 3 over 2. Now I want to figure out what angle would give me a positive root 3 over 2 for sine. There used to be multiple answers, but now because of the principal solution, there's only one answer, and that is actually positive pi third. And I'm going to check that this falls within my range for sine. It's got to be between negative pi over 2 and pi over 2, including. Okay, so it works. All right, we're also then going to do this example problem with tangent. So I'm going to do the same thing. I'm going to work inside out. So I need to know what is tangent of 5 pi over 6. So tangent of 5 pi over 6 happens to be negative root 3 over 3. Or if you prefer, negative 1 over root 3. So now we're asking ourselves, where is tangent equal to negative root 3 over 3? And we want to use the principal solution set for inverse tangent, which is also negative pi over 2 to pi over 2. So our feeling is we want to use 5 pi over 6 because that's what we started with, that 5 pi over 6 is not within this range. So I have to pick an angle that is within that range. And the angle that would fit that is the angle in the 4th quadrant, but negative angle. So this is going to be negative pi over 6.